electrolysis. Okay, it's done in an electrolytic tank. So first, what is this electrolysis itself? If you look at this word, we have two words here. Electro, okay, from the word electrons. And of course, lysis or lysis simply means to split. Okay, to split. So electric current is the flow of electrons from negative pole to positive pole. So electrolysis has to do with the decomposition. Electrolysis is the decomposition of compounds in molten or solution form, by the what? The passage of electric current. By the passage of electric current. Essentially, what we are saying is that electrolysis happens when electric energy causes chemical reaction. So electrolysis takes place when electrical energy causes chemical reaction. Now, the chemical reaction, what type? Because we have different types of chemical reaction. There are different types of chemical reaction. Now, this chemical reaction is what? A decomposition reaction. Okay, so electrical energy actually what? Causes what? Decomposition reaction. So the kind of chemical reaction we are talking about here is a decomposition, splitting, breaking. Okay, so if I have water, for example, and water undergoes chemical reaction and it produces hydrogen and what? Oxygen. Hydrogen and oxygen. This is an example of what? Decomposition reaction. That means water was broken into its what? Elemental form. Okay, was broken into its constituents. That is decomposition. So electrolysis happens when the passage of electric current, the flow of electron, okay, causes chemical reaction to take place. And the chemical reaction is a decomposition or a decomposition reaction. So if I have sodium chloride and it breaks down into sodium and what? Chlorine. Not chloride now, sodium and chlorine. This is a decomposition or reaction, meaning that a chemical change has what? Taken place. Don't forget that chemical reactions are different from physical reactions, are different from physical changes. In chemical changes, new substances are what? Formed. And of course, if you look at this, water breaking down to hydrogen and oxygen, new substance is what? Formed. Water is different from oxygen, and hydrogen is different from what? Water. And in fact, they have opposite what? Opposite reaction. Oxygen supports combustion, but water extinguishes fire. So you can see that a new substance is formed. So this qualifies as what? As chemical change, because new substances are formed. So these are examples of what? Chemical decomposition. And so in electrolysis, whenever electrolysis takes place, you are decomposing a chemical compound. That is the meaning of what? Electrolysis. But that decomposition was made possible by using electrical energy. So electrical energy somewhat supply the activation energy required for the chemical reaction to what? To take place. So that is the meaning of what? Electrolysis. Now, what kind of substance can be electrolyzed? We call them what? Electrolytes. Okay, so an electrolyte is a substance, okay, that conducts what? A substance that conducts electricity, right? That conduct what? Electricity, either in molten or what? In solution form. Okay? and that substance must be decomposed. It's not just conducting electricity. Conduct electricity, it could be in molten or what? Or in aqueous what? Aqueous form. Okay? And it's what? It becomes decomposed. It becomes decomposed by it. Mean it becomes decomposed by the passage of what? Of electricity. Otherwise, if it's not decomposed, it won't be called an electrolyte. It will be called a conductor. So if you look at the conductors allow passage of electricity, but they don't get decomposed by it. So that's why we call it a conductor. So an electrolyte is different from a conductor, even though an electrolyte itself conducts electricity. But in addition to conducting electricity, it becomes decomposed by the conduction of what? Of electricity. Do you understand that?
Yes.
Usually, ionic compounds are good what? They are good electrolytes. Okay, ionic compounds are good electrolytes, and acids. Okay, some covalent compounds are also good what? Electrolytes. Acids are covalent compounds, but they are good electrolyte because they are compounds of intermediate character. I mean, sometimes you may wonder how come acids are covalent compounds, but initially, especially in your year 10, you were taught that covalent compounds don't conduct electricity, while ionic compounds conduct electricity, you know. But some covalent compounds that have intermediate character can conduct electricity. And good examples are what? Are acid, especially strong acids, nitric acid, sulfuric acid. Okay, they are strong acid. And one of the reasons why they behave that way is because of this hydrogen. You know, hydrogen is a very funny element. It's the only element in the periodic table that is a non-metal, but somehow could be classified into group 1 element because it's possibly charged. You can lose electron out of all the non-metal. Okay, hydrogen can easily lose electrons. So if a compound contains hydrogen, it may want to act like what? Like an ionic what compound. Do you get that point?
Yes.
Okay, so that's electrolyte. Okay, so the next thing we want to consider will be electrodes. Electrodes, we look at electrodes, but now I need to just depict. Okay, I didn't just want to take pictures or something. I really want to take everything from scratch with you so that you get it. So if this is my electrolytic tank, so I have my rod that represent my electrolytes, my electrodes. Then I have the electrolytes. So I have the electrolytes here, okay? Then I have my terminal, so I can connect this to a battery, okay? So now in this particular situation now, if this, let's say this is my negative pole of the battery, this is my positive pole of the battery, okay? So you would expect that this particular electrode will also be a negative word electrode. That will be a negative word electrode, while this will be a positive word electrode. Okay? So now your positive electrode in electrolysis, your positive electrode is called what? Anode, while your negative is called what? It's called cathode. Okay? So basically electrodes are rods or plates through which electrons enters or leave the world, the electrolyte. Electrodes are rods or plates through which what? Electrons enters or leave the world, the electrolyte. So it's very important to understand that. Now, we have seen the electrodes, cathode and what? Anode. They are rods of opposite what? Opposite charge. Now we have our electrolytes here. We have electrolytes here. Let's say we have sodium was sodium chloride. And I've recalled earlier for you how a particular substance could have, a positive electrode, negative electrode, and how you can determine the ions that are present in a given species. Like sodium chloride now, we looked at the kind of ions that could be present, in molten or in aqueous form. And this is where you will use that knowledge, okay? So if you have electrolyte in an electrolytic tank, this is called an electrolytic tank, and you connect your terminals to the source of electricity. Don't forget that we said electrolysis happens because electric current causes electrical chemical reaction to take place. So basically, this is where you have your electric current, okay? You have your electricity being generated here, where you have your chemical reaction taking place here. It's a need to be very attentive. You have your chemical reaction taking place in the electrolytic tank here, okay, while your electricity is being generated here. This is called an electrolytic tank, okay, or an electrolytic setup. This is different from an electrochemical cell, like your battery. In your battery, chemical reaction produces electricity. So in battery, it is the reverse. But in electrolytic cell, electricity is generated to cause chemical reaction to take place. So now we have connected our terminal to the battery, to the source of what? Electricity. So we would expect that electric current will flow. Now this is the direction of flow of electric current. It flows like this. Can you see? It goes that way. Okay? It goes that way. Just take it that way. It goes that way. Back. Okay? So your cathode is the negative electrode through which electric current or electron, if you like, through which electron enters into the electrolyte. Okay, electron enters into the electrolyte here. While your anode is the positive electrode through which electron leaves the electrolyte. You got that right?
Yes, sir.
Okay, so you just flow like this, arrow, flow like that, arrow. Okay, so having laid out this foundation, let us now see what happens to, so I'm going to take example 1. Now I want to look at examples of electrolysis. Example 1, we'll look at electrolysis of molten sodium chloride. So we are first considering electrolysis of molten compounds. Electrolysis of molten compounds. So look at electrolysis of what? Of sodium chloride. Electrolysis of sodium chloride. Now, for electrolysis, there are steps. So what are the steps for any electrolysis? What are the steps for any electrolysis? Number 1 step. The first step that you have in electrolysis is what we call dissociation. Dissociation, especially if it is aqueous, okay? Or basically just call it splitting in case it is not splitting, or what? Splitting of ions. Then number 2, we have what we call migration. Migration of what? Of ions. And number 3, we have what we call the discharge. The discharge of what? Of ions. So for every electrolysis that you're going to treat, you follow these steps from beginning to the end. Dissociation means the ions will split. The compound that you have will separate into individual ions. Then the ions will migrate to what? Electrodes of opposite charge, because unlike charges attract. Because unlike charges attract. Now, the third thing is discharge of ions. Discharge of ions. Discharge of ions means what is going to happen to the ions when the ions get to the electrodes. What is going to happen to the ions when the ions get to the what? Get to the electrodes. What's going to happen to it? That is what we have here called discharge of ions. So usually the ions will be converted back to their elemental form. The ions will be converted back to the elements. It could be forming gases or metal being what? Deposited. If it's a metallic ion will be discharged as metal, solid metal. Okay? If it is a non-metal, non-metals will usually be deposited as what? As gases or what? Or liquid. Okay? Yeah. Non-metal elements. Gaseous or liquid, non-metallic what? Element. Okay? Or volatile solid like iodine, vapor. Okay? Which could later form a sublimate on the electrodes. So let's now follow these steps to take electrolysis of molten sodium what? Sodium chloride. Okay? We can proceed, right?
Yes, sir.
Okay. So electrolysis of molten sodium chloride. Good. So we said since it's molten sodium chloride, the first step is splitting of ions, right? The ions what? The ions will splitting of ions. The ions will split. So what is the ion in sodium chloride? When it splits, they split into what? Sodium plus and what? Chloride ion. Do you agree with that?
Yes.
Okay. So if this is the case, now this is a situation. So having splitted into this. Number two, we have what? What's the number two step? Can you recall that? Number two.
So was it to the migrations of
Brilliant. Migration. So it's going to migrate. So now we have migration. Migration means where is it going to migrate to? So let me just to give you a pictorial representation here. You have your negative and you have your what? Positive. Okay. This is your what? Anode. While this is your what? Your cathode. Cathode is negative. Cathode is what? Negative. Okay. So you would expect that since unlike charges attract, that is the rule. Okay, unlike what? Unlike charges attract. So you would expect that your sodium ion will migrate to this, while your chloride ion will migrate towards to this. Do you get that? So
yeah.
Good. So migration now, I'm going to be having anode, then I'm going to be having cathode. So I'm having two sides now, anode, cathode. So at my anode is what? Electrode, positive. Cathode is what?
Negative.
Negative, okay? So now for my anode, I know that chloride will get there, right?
Yeah.
Then my cathode, I know that what? Sodium ion will get there. Good. Now the third step is called discharge of ions. Discharge of ions. Discharge of ion. What that simply means is that what is going to become. To discharge means to release, to let go. Your chloride that is in the solution, or in this case that is in the liquid, because it's molten, liquid, it's liquid. The chloride that is in the liquid form, this is L, liquid, okay? And the sodium that is in the liquid form will now be what? Discharged, will be released. But your chloride will be released as chlorine gas, while your sodium ion will be released as what? As sodium metal. Sodium metal. So the question is, how do you think chloride will become chlorine? How do you think chloride will become chlorine?
So it will you like try to confirm? Does it like use electrons?
Okay. So a quick recall on that. Okay. You guessed right. I guess you weren't sure, but you were correct. Okay. So please look at what I'm doing. This is chlorine, right?
Yes.
And it's a non-metal. For a non-metal to become negatively charged, you know, non-metals for negative ions, what would happen to it?
So it has to gain electrons.
Brilliant. Are they brilliant? So it's gaining what? Electron, right? Now, if it wants to go back, what will happen to it?
You have to lose.
It has to lose the electron. So for it to form what? Chlorine back. The same thing with a metal. Okay? A metal will lose the electron to form a what? Metal ion, right?
Yes.
So if it wants to go back, it's going to what? It's going to gain the electron to form what? To form metal back. Brilliant. So let's apply that here. This chloride wants to become chlorine. So we said it's going to do what?
It's going to gain. Lose, sorry.
It's going to lose electron. Brilliant. It's going to lose electron. So it's always good to go from the first principle. It's going to lose electron to form what? Chlorine. Can you see that? Yeah.
Yes.
But we know that chlorine gas is a diatomic molecule. Okay, so it's going to be Cl2, right? So multiply everything by what? By 2. You got this concept, right?
Yes, sir.
Okay, so we got that Cl2. Now, sodium ion 2 to be discharged. Sodium, as we have deduced, is going to gain what? Electron. To form what? To form sodium.
Yes, sir.
Okay, so just as a matter of rule, number of electrons lost must be equal to the number of electrons gained. If 2 electrons are lost, 2 electrons must be gained. So we multiply this equation by 2. So therefore, we are going to be getting what? 2 sodium, 2 electron, and 2 this. Mind you, the way we wrote this, there is nothing like sodium 2 standing alone as element. No. Metals are not polyatomic in terms of the atoms forming molecule. Metals don't form molecules, so this will be wrong. So you can put Na2. So it is 2Na, telling us we have 2 sodium 2 atoms of sodium formed there, or 2 moles of sodium. Then that means 2 moles of electrons will be gained by 2 moles of sodium ions. Okay, so we have been able to see these. Now, that tells us that the sodium chloride, okay, plus sodium, if I'm combining the equation together now, 2 chloride, 2 sodium, when they split, they are going to form what? Cl2 plus what? Plus 2Na. So you can see now we have been able to what? To separate chlorine plus from what? From sodium. So sodium, molten sodium chloride has undergone what? Electrolysis. So we have been able to split sodium chloride into what? Into chlorine and what? And sodium. Not chloride and sodium, but chlorine and what? And sodium. So we went through all the steps, for your electrolysis, from splitting of ions to migration of ions to what? To the discharge of ions. Okay, so what you need to be able to do here and recognize is you must be able to recognize in which of the electrodes do we have oxidation and in which of the electrodes do we have reduction. So that is what I want you to tell me now. What do we have at the anode? Is it oxidation or reduction?
Answer is said oxidation.
Why do you say it's oxidation?
So because it's using electrons.
Brilliant, brilliant. So on the cathode, what do we have?
So reduction.
Reduction. Why?
Because it's gaining electrons.
Because it is gaining what? Electrons. So sometimes they can tell you, write the oxidation half equation. They may not say write the equation of what happened at the what? At the anode. No, they just say write the oxidation what? Half equation. This is a half equation. This is the second half. Combining them together form what we call what? Redox. Reduction and what? Oxidation. Reduction and what? Oxidation. So combining them together forms what we call what? Redox reaction. So you can see here, your chloride is oxidized to what? To chlorine. It's moving from -1 to 0. While your sodium ion is reduced to what? To sodium. It's moving from +1 to what? To 0. Isn't this interesting?
Yes, sir.
Yeah. Okay. So that is one example. One example. Okay. So I'll do one more example, which you're going to talk me through. As I say it, I'm going to write it. Okay. Can you see my steps? I follow these steps: splitting, migration, discharge. So I'm going to pick another molten compound. So you're going to tell me what's going to happen from splitting, the type of ions, the migration, and to the discharge. Are you ready?
Yes, sir.
Okay, so that will form our example 2. Example 2. Now, we'll look at electrolysis of molten lead bromide. Electrolysis of molten lead bromide. Okay, so start from splitting. That is your step 1. So just speak. I'll just help you write.
Okay. So you first add the anode.
Anode.
Wait, so okay, so when you first put it, you first have lead and you have bromide ions.
Okay. So last lead bromide. So what's going to happen to this?
So they split up to lead and bromide, lead ions and bromide ions.
Okay. You want to trick me at this one. So what is lead ion? What is the charge?
So I think it's 2.
Smart girl. Okay. 2 plus, correct. 2. Molten, yes. Bromide.
So is it 1 or 1?
What is charge? +1, -1.
So -1.
-1. So liquid. Now you can see it is 2 that I have here. To balance it, would it be good to have 2 here like this?
Yes, sir.
Okay. So you skate through that. Next one will be what?
But then you have your migration of ions.
Okay. So next.
So you have your anode, which is positive, and you have your cathode, which is negative.
Okay. So migration. So now you said we are going to have a cathode, which is what? Negative electrode, and what? Anode, which is what?
Positive.
Okay. So which one will migrate to the cathode?
So it will be the lead.
The lead.
Yes.
Okay. PB 2 plus comes here. Okay. So which one migrates to the anode?
So the bromide.
Bromine minus. Okay. So step 3, discharge. So what's going to happen at the cathode? What's going to happen at the cathode?
So at the cathode, the lead is reduced. So it's PD PD2 plus minus 2E will give you like lead ions.
I'm going to write exactly what you said. You said it will be reduced, right?
Yes.
And you said it will be Pb2 plus minus 2E minus, is that what you say?
Yes.
Okay. So if it's going to be reduced and it's losing electron, does that tally with the definition of?
Oh no. It's losing its oxidation.
So what's going to happen to lead ion?
It's going to be reduced.
It's going to be reduced. So for it to be reduced, what will happen to it?
So to gain electrons.
Brilliant. It will what? Gain electron. Remember, oxidation is a loss, reduction is the gain. Oxidation is a loss, reduction is the gain. Oxidation is a loss, reduction is the gain. Or if you like, oxlo-reducer. Oxlo-reducer. Oxlo, oxidation, loss. Reducer, reduction, gain. Okay, that sounds too verbose, right? So just stick to your oil rig, okay? Oil rig. Reduction is gain, oxidation is loss. So since you know that it's going to be reduced here, there must be gain electron. So now if it gains electron, it's one word, Pb, okay? So this Pb solid will now be deposited on the negative one electrode. That is your cathode. So your cathode will be growing bigger in size. Your cathode will be growing bigger in size. So if for example, this was the cathode, which is negatively charged, and this was the anode, which is positively charged, you will notice that your lead will be getting attached, okay? Lead will be getting attached to what? To this. Lead will be getting attached and it will be growing bigger and bigger and bigger and bigger. Lead from the solution, okay? Lead from the solution, if this was the tank, lead from the liquid will be migrating to this place and getting attached to it. While your bromide, okay, so I'll wait for you to get there. So that's just the concept of electrolysis. Very interesting concept and very, 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 okay, so let's move on. You got this Pb. So what happens to your bromide?
So it's oxidized.
It will be oxidized. So what does that mean in terms of equation?
So it means that it loses electrons.
It loses electron. Okay, it loses electron. So that means minus 2e minus, or how many electrons will it lose?
So it should lose one. No, so you lose two.
What group does bromine belong to?
One.
What group does bromine belong to?
Oh, so I think group 7.
And that's why you asking me group what?
So 7.
Oh, you're not sure. You're saying 7, and you're asking again. You should be familiar with your periodic table. I mean, always have it beside you, because in exam, you're going to use it anyway. Do you get that point? You're going to use it anyway. So get familiar with your periodic table. Bromine is in group 7, you're right, but you're not so sure. Bromine is in group 7. So if it's in group 7, what does that connote about the valency of bromine? What's the valency of bromine?
So 1.
Yes, 1. So it means that the combining power of bromine is 1. So it's going to, bromine will gain 1 electron to form bromide ion. 1 bromine will gain 1 electron to form bromide ion. So therefore, okay, your bromide ion will lose 1 electron to form what? To form bromine. It is after it has been lost, it has formed bromine, that bromine will now combine to form diatomic. So we have 2 of these will be formed. Therefore, to form 2 of that, we must have lost 2 electrons, and what? 2 bromide ion must have come together. Do you understand the concept now?
Yes, yes.
Okay. So this is what will happen. Okay. So luckily, if you look at this, number of electron lost equals to number of electron what? Number of electron gained. So sorry, let me take my power. Number of electron lost equals to number of electron what? Number of electron gained. So the next thing here is to now look at the overall what? Overall equation. The overall equation is, okay, can you describe the overall equation for me?
Going to be PB2R dash
PB2 or 2 plus, did you say 2 plus?
Yeah.
Plus what?
Plus 2BR.
Yes, 2BR. BR minus. Okay.
Then arrow.
Okay.
So BP plus.
PB plus. You mean plus like this or plus at the top?
So no, plus like that.
Okay.
Plus BR2.
BR2. Okay. So this will be solid. This will be liquid. Okay. Yeah. So correct. This will be your overall equation. Number of electron lost plus number of electron gain. So you can see that your bromine PBBr, which is this, okay, and this is the ionic representation of it, okay, has been splitted or has been split into lead and what? And bromine. Okay. So that tells us that what? Electrolysis has taken place. The splitting, the chemical decomposition caused by the passage of what? Electricity. Okay. So basically looking at this, you can tell us where do you have reduction between the 2 electrodes, cathode or anode?
So repeat your question.
Where does reduction take place? Or where did reduction?
So it takes place in the cathode.
In the cathode. Okay, so here, that's where we have what? Reduction. Why anode is what?
Anode is oxidation.
Anode is oxidation. Okay, so it's pretty that simple. Electrolysis of what do you call it? Electrolysis of molten compound it's not difficult at all. Okay, so but because we have laid this strong foundation for this, you will not have issues when we look at electrolysis of aqueous compound. So I want you to hold on to something here. That is this mnemonics that I use. Okay, I call it CROW. Okay, so that helps my student to remember that at the cathode, what you have is reduction. While at the anode, what you have is what?
So oxidation.
Would this be helpful?
So I think oil rig still is more memorable. I think oil rig is so memorable to me.
Yeah, the two of them, okay, do different things. Oil rig helps you to define oxidation, helps you to know what is going to happen during oxidation. During oxidation, you have loss of electron. During reduction, you have gain of electron. But this second one helps you to know where will oxidation take place and where will reduction take place. This one tells you cathode. At the cathode, what do you have? Reduction. At the anode, what do you have?
Oxidation.
Yeah, you can see they are doing two different things. Okay. Yeah, so this is, I'm pretty sure you may not have seen this anywhere in this world. Okay, because I designed that. That's CROW. So it helps you to understand what takes place at the cathode and at the anode, so that you won't be trying to like, okay, now at the cathode, what takes place is reduction, oxidation. When you remember your CROW, so you just look at cathode now. Cathode is reduction. So you now go back to your oil rig. Then you now ask yourself, what is reduction? Reduction is gain. Then you now know that you are adding or plus. Do you get that at all?
So are you there?
Yeah.
Oh, so your light went off like a minute ago.
Oh, that's your network. So I was trying to reiterate, okay, emphasize the use of these two mnemonics. Okay, the second one helps you to know what happens at a particular electrode. So C, cathode, means R, reduction takes place at the cathode. So now you know reduction takes place at the cathode, but the next thing is, am I adding electron or am I removing electron? So you now go back to your what? Oil rig. Reduction is gain. That means you are adding electron. But if you say anode is oxidation, then you know that at your anode, you are doing oxidation. But the question is, what is oxidation? Oxidation, according to oil rig, is loss. So therefore, I come back to this and say -2, then I'll get that. So combining these two will help you a lot. Is that okay?
Yes, sir.